Hello and welcome to Unit 1.3 of Module 1. In this course, we're going to go on a short historical tour of the development of risk-based approaches in the water sector. At the end of this module, learners will be able to understand the historical context of risk management for water reuse, describe two approaches to the development of water reuse laws and guidelines, and identify the three main concepts that combined to create the modern risk-based approach in the water sector. To help understand the development of risk-based approaches in the water sector, it helps to first see some concrete examples from history. One of the first regulations on the subject was implemented in the state of California in the USA in 1978. Historically, having limited reliable water resources, water reuse had been regulated by the state government from as early as 1918. The World Health Organization developed its first guidelines for water reuse in agriculture in 1973. These guidelines would be updated periodically, roughly each 10 years, with the last major update in 2006. The approach taken in California required the adoption of the most advanced and best available technology to treat wastewater in order to ensure it met a long list of restrictive quality limits. By some, this was termed a zero-risk approach and was possible only for the most technologically developed and wealthy countries. The World Health Organization recognized the limitations of this approach for many countries around the world, and through subsequent editions of its water reuse guidelines, developed an approach based on fewer quality parameters with less strict limits. It attempted to develop a framework based on real-world health data and epidemiological research that suggested that the risks posed by water reuse were not always as high as the Californian approach implied. A risk assessment and risk management framework was developed and promoted to developing countries rather than the adoption of strict quality limits. The most recent WHO guidelines on water reuse are from 2006. They include 4 volumes dedicated to policy and regulatory aspects, wastewater use in agriculture, wastewater and excreta use in aquaculture, and excreta and greywater use in agriculture. But how did we get here? Well, the development of these guidelines drew heavily on innovations from the food industry and drinking water quality management. So let's look at some history. The World Health Organization is a specialized agency of the United Nations responsible for international public health, established in 1948 and headquartered in Geneva, Switzerland. Its first international drinking water quality standards were published in 1958. During the 1960s, the US Aeronautics and Space Agency, or NASA, and the food company Pillsbury developed a system to ensure the safe production and delivery of food. It's called Hazard Analysis and Critical Control Points, or HACCP, and is a systematic preventive approach to food safety from biological, chemical, and physical hazards in production processes that can cause the finished product to be unsafe. The system designs measures to reduce these risks to a safe level. In 1973, the WHO released its first guidelines for water reuse in agriculture. In 1980, along with the International Commission on Microbiological Specifications for Foods, the WHO published a report on the HACCP approach, and in 1983, the WHO in Europe recommended the adoption of HACCP principles. In 1982, the WHO shifted from releasing drinking water quality standards to guidelines, and in 1984, it published the first edition of its guidelines for drinking water quality. The Food and Agricultural Organization, or the FAO, contributed in 1985 with its water quality guidelines for irrigation, which included recommended maximum concentrations of trace elements in irrigation water and the physical and chemical water quality to accommodate plant growth. These were later incorporated into the WHO water reuse guidelines. The second edition of the WHO water reuse guidelines were released in 1989. In 2001, a major development occurred in the management of drinking water quality. Following an expert meeting in Stockholm, Sweden, the WHO published the Water Quality Guidelines Assessment of Risk and Risk Management for Water-Related Infectious Disease. This report provided a harmonized framework for the development of health-based guidelines for water and sanitation-related microbial hazards. This framework, which incorporated elements from the HACCP principles, recommending an integrated risk assessment and multi-barrier risk management approach. The framework was included in the third edition of the Drinking Water Quality Guidelines in 2004 and the third edition of the Water Reuse Guidelines in 2006. And it's the risk approach presented in these guidelines that is the basis for many subsequent guidelines and regulations around the world, including the 2021 EU regulation on water reuse in agriculture. Pause the video to look at the timeline in more detail. So, without going into too much detail of each step along the way, this should give you a broad overview of the main concepts involved in the development of risk-based approaches in the water sector and how they fit into water reuse. There has been a strong influence from the food industry risk practices through the HACCP principles, as well as from the Stockholm Risk Framework for Drinking Water. In addition, risk in water reuse has developed in concert with agricultural concerns for irrigation water quality, both microbiological and physicochemical. And finally, here are 3 key takeaways from this lesson. From a historical perspective, we saw that the initial risk-based approach was developed from the HACCP principles, a system to ensure the safe production and delivery of food. We also saw the development of 2 approaches to risk based on the needs of the time and place, the so-called zero risk approach in California, and a more balanced risk assessment approach from the World Health Organization. And lastly, we looked at the Stockholm Framework for Drinking Water Risk, which is the basis for most modern risk assessment approaches to water reuse. It includes HACCP principles, a classic risk assessment framework, and a preventive multiple barrier approach. Thanks for your attention, and don't hesitate if you have any questions.